Welcome to this session of Wind Power Project Management Podcast. My name is Milan. I'm the host today. I'm studying Wind Power Project Management in the 2 years program right now here on Campus Scotland. Our today's topic is a little bit more focused on wood or timber towers and wood in general in wind power. And before we dive into the topic, I would like to announce our guest today. It's Anders Wickström. Warm welcome.
Thank you very much. Thank you.
Anders is working as a project manager at RISE and is also a researcher there. Anders, RISE is like the name for research institute in Sweden. Could you maybe give us a broad idea what is RISE doing, or what is the purpose of RISE?
Yeah, the purpose of RISE is to be kind of a link between the university research areas and the industry needs in Sweden.
Okay, and the way I understood it, you're focusing mostly on like bringing the industry forward in the sustainable development.
Yeah, I mean, RISE is working in a very broad range of areas. Some 3,000 people. But my unit is called Renewable Energy Systems. We are focusing on how to integrate renewable energy into the energy systems in a resilient and economical good way. And it's quite a lot on wind power, of course.
All right. Okay. When we look a bit more into the topic of today's podcast, so when we see the wind industry in general, we do have a majority of towers made from steel, and we also do have some concrete towers. There's another opportunity, which would be like building towers, for example, out of wood, so timber towers. And I think there's kind of a trend. Would you also, before we go into the details, see like a trend, or is it more like in a niche, a new idea of building towers or also blades?
In towers, I see it as a new trend because the wind turbine manufacturers also want to produce or offer a product with zero carbon emissions. And one way to reach that goal is to eliminate the carbon footprint from the tower, which is a lot of steel. And a proof of that is that Vestas is investing in Modvion and have some shares in that company. So that's a sign in this direction.
Yeah, maybe for our listeners, Modvion is, I think, one kind of a leading company in Sweden, in Gothenburg, that is developing and building these towers.
Exactly. There has been other timber towers, one in Germany, but that was more on another kind of technique, which was more labor-intense technology. But this is kind of simple, I would say, by using laminar veneer to create a circular tower shape in a factory, and then just erect everything on site.
Yeah, I was talking about the footprint, for example, of steel towers. So the footprint of timber towers is, from the first perspective, definitely way lower, because it's
even negative.
Yeah, it's negative because it's storing the carbon for long term. When I read about the LBL structure the first time, I was thinking, what about the resin? Because when you go to decommissioning of the wooden turbine tower, you could use it for building in usual houses, for example, and it would also, of course, decompose like usual trees. But how about the resin in between?
I mean, that's simple wood glue between each layer of laminate in here. It's very basic but strong. So that's in that respect, it's no difficult material. The potential issue is maybe the outer coating, which is more sensitive, and that's not for gluing, but that's for protection against weather and
Different
snow
weather conditions.
and hail and everything
Yeah.
can occur.
I think this brings us to the next topic. Usually we do have humidity issues with wooden structures. So how would you say is it handled in case of turbine?
Well, yeah, but in the beginning of the rail transportation era, we built railway stations from iron, and they didn't last for a long time because of the steam coming out from the locomotives. So they started to rust extremely quickly. And then they are designed in Stockholm and Gothenburg by wood, and in the beginning of the 20th century. So it's more than 100 years old, and still going strong. So we have a lot of, and also walk around here in Visby and look at the old buildings made from wood. So you see that wood is a sustainable material.
And how about when we talking about the coating that you were mentioning? So we seal it up from the outside weather conditions, but isn't there still humidity inside the tower, or how is it regulated?
Yeah, well, I mean, they control the humidity inside by a dehumidification system, which is a common system in museums and different applications, and it doesn't consume much power to run that. So they control the humidity inside the tower.
Okay.
So in that way, it's very sustainable.
When we look at towers, or maybe also blades from the technological side, so when it comes to stiffness, durability, so is it strong enough in long term compared to steel, for example?
Yeah, I think, I mean, the fatigue properties of wood is good. The tricky thing is this connection, which is made from steel plates, high strength steel from SSAB, which are glued they cut in the wood and then they glue these steel plates, which are perforated. So that has been very much checked in our laboratory at RISE for both ultimate loads and fatigue loads. And we notice that the failures occur. We want the failures to occur in the steel, and it does. So the steel properties, we know very well the steel properties. So when we have the failures, both from fatigue and ultimate loads in the steel, then we are comfortable.
So it's kind of more predictable when you design it that if something breaks, then it's the steel. And the steel, you definitely know when it will break.
Exactly. Yeah. So that should be and is the weakest part of the chain, even though it's a super high quality SSAB plate that we are using. It's not ordinary steel, but it's high strength steel.
Wait, you were already mentioned like the tower is made in sections, which might also be a big opportunity for transportation reasons. Could you explain a bit more how?
If you look into the cylinder, I mean, it's cut in cakes, in sections. So to build one cylinder at site, you have 4, 5, or 6 segments that you make a cylinder out of on the site. and
so
then
way smaller.
you do the next cylinder section, and then the next, and then the next, like an ordinary steel tower. But you put it in place on the site.
Okay, and these smaller sections are prefabricated in the factory, and then usually can be transported on small trailers because you just don't have the.
Well, you have the same. I mean, they are designed to fit to the transportation systems, so they are as large as possible to be transportable. Of course, the larger sections you can manufacture in factory, the better, of course.
So just that we have a bigger diameter at the bottom, and this is the advantage that we have. So we can still transport it more or less easily on the roads, but are able to have a bigger base diameter.
Exactly, and of course a bigger thickness, wall thickness. With probably you have a larger diameter at the base for a wooden tower than an ordinary steel tower.
Okay, all right. Another thing one could think, okay, if we put up a timber tower, what about fire? We do have fire hazards, I guess, or what would you say about that?
Yeah, we have tried to make fires around this. So we have produced sections of timber tower in our laboratories and put different kind of fires in front of it.
So you try to
set the fire.
Okay.
And what happens is that when our fire burns, I mean, you get a coating or a coal layer, which works then as an isolation to the inner part of the wood. So it doesn't burn, actually.
It's more charged from the outside or from the inside if it's inside the tower?
Yeah, exactly. Yeah. It's very difficult to put it on fire. However, coating, then it's a bit more sensitive to fire, because that paint itself is easier or is less resistive to fire now. Yeah.
Okay, and when it comes to lightning strikes, for example, I think it's then the same reasoning as you were mentioning before. So we do have issues with lightning turbines in general, but it's manageable and not worse when it's a timber tower.
Yeah, I mean, the difference, well, even in a steel tower, I think you have a lightning rod inside, and lightning rod. I mean, if it hits the blade, it goes all the way through the turbine. And I think, at least in the timber tower, you need to make sure that you have the lightning inside your rod and then properly to the earth.
Yeah. Right. In general, to maybe sum up, it sounds quite promising, the idea of using wood, and maybe coming back to the antitrust question about if it is a trend. You said you do see timber towers as a trend also for large companies like Vestas. So you would say it is something we might see more in the future, or is it still hard for the companies to implement it because the steel tower section is quite a strong one, I think?
I think that Molvion has a good business case. I mean, it's easy to scale up the production, but that's a process that they are doing now. I mean, the first tower, the 30 meter for the research turbine, it was all handmade in small factory by the engineers, basically. And then they have now built this manufacturing facility in Gothenburg. But that is not, I mean, you can't produce too many towers there per year, so they need and are about to scale it up to next facility, but it's basically copy paste because it's simple materials, have a robot doing the cutting and all these things, very very accurate. That was my a concern that I had to cut each section to fit with this steel plates.
You have a very, very small margin.
You have small margins, but this robot technology is just fantastic, how it can cut perfectly and how it fits. So, I mean, we have been through most of the technical issues that we anticipated or the challenges from the beginning, but now it looks very promising, and they are scaling up, and I don't know about the economics about it, and that's of course a commercial thing to to handle, but I'm quite convinced that we will see timber towers coming in the future. Yeah, maybe it's more a bit more challenging for blades with the erosion thing and things like that. You need maybe a bit more maintenance to make sure that you have, or maybe have another coating for the bleeding edge for a blade.
Yeah.
In principle, the technology is quite simple, but you need to invest a lot to get it certified, to make sure that all these questions that you raise and all these issues are properly solved. That's an investment, but once that is done, then copy.
Yeah.
So,
all right. So you mentioned that basically the technical challenges are more or less solved. So
I think so. I mean, of course, we need to. We don't have any towers that have been up, the modern towers, for 20 years yet. So of course that's also to be proved.
And long term.
But it's long term, yeah. But day after day, we we get more data.
That sounds good. All right, then thanks for this so far. And I mean, we as wind power students are always happy to get some tips from professionals. And is there something like a personal advice you would give to our wind power students for the future, also in the wind power industry in general?
Well, a good question. When I go to different conferences, one issue that I hear many ask about, that's how to get people in the area, how to get people with knowledge. How do we really, because it's growing so fast.
So you would say we are already heading in a good direction.
I would say, yeah, I think so, yeah. And the interesting thing with wind power is that it's so many areas, starting from knowing something about the wind, knowing about aerodynamics, materials, control system, and everything about wind farm design and how to configuration of turbines, and even how wind farms interact between each other. And then you have all on the electrical side and all this with how to integrate it into the electrical system and robust electrical system, and all other aspects, wake control, things like that.
So there's still a lot to do.
There's still a lot, yeah, of course. So
we'll keep working on that.
I think, yeah, you have a good future to look forward to, yeah.
Okay. Then thank you very, very much, Anders. It was very interesting, the guest lecture in the morning and also the podcast now. Thanks for being here, and thanks a lot.